Hello everyone, this question is from GATE 2020 Electrical Engineering. A single 50 Hz synchronous generator on roof control was delivering 100 megawatt power to a system. Now due to an increase in load, generated power had to be increased by 10 megawatt, as a result of which system frequency dropped to 49.75 Hz. Further increase in load in the system resulted in a frequency of 49.25 Hz. At this condition, the power in megawatts supplied by the generator is dash. We have to find out the power supplied by the generator. One can refer to the NPTEL course as mentioned here. Now, the useful data to solve this problem is the droop in the speed of the prime mover that is connected to synchronous machine, which is given as the ratio of difference in speeds at no load and full load and the speed at full load. If we plot the curve between the power output of the generator and the speed of the prime mover, will get a graph like this. Now, as we know that the speed and frequency are related to each other, so we can express the droop in frequency as similar to our speed droop, right? Now, the quantitative relation of the frequency and power can be written as P equals R FNL minus FFL, where these terms have their usual meanings, with R as the slope of the characteristic curve that is plotted between the frequency and power of the generator. So this is the slope of this curve, and that is represented by R, and it is measured in kilowatt per hertz or megawatt per hertz, right? Now let us solve this problem. So the generator is supplying 100 megawatt power at 50 hertz frequency, right? So if now I plot the curve between, say, power and frequency, I'll say this is the curve which I get, right? So at, say, this is our 50 hertz, right? Say this is 50 hertz. At 50 hertz, the power that is delivered is, say, how much? 100. Okay. Now there is a drop in the frequency to 49.7 hertz, right? And there is a increase in power by 10 megawatt, right? So what I'll say, if there is a droop in frequency, say if there is a droop in frequency, then there is a increase in the power, and this is, say, 110, right? And this is in megawatts, fine. So this is 49.75. Again, I can say that if there is a change in demand, say given by del P, that will be equal to how much? Say 110 megawatt minus 100, that will give us 10 megawatt. And similarly, the change in frequency, of course, due to increase in load, that is del F will be how much? 50 minus 49.75, that is 0.25 hertz, right up till here. Now we have seen that there is a relationship between the change in frequency, the change in power, and the slope of this characteristic curve. So the slope, that is speed regulation, it is also known as, that is R is given as del F by del P. So del F is 0.25 and del P is 10, right? So R comes out to be 0.025 hertz per megawatt, right? So further it is said that there is an increase in load in the system and it resulted in a frequency of 49.25. So the frequency further falls. Say this is 49.25, right? And at this condition, we have to find out the power in megawatts supplied by the generator, right? So let the corresponding power be this. Okay, so the power supplied by the generator at 49.75 is 110 megawatts, right? 100 plus 10. So similarly, if our new frequency is say 49.25, then what will be the change in frequency? What will be the change in frequency? That is say del F dash, that is equal to 49.75 minus 49.25, which will give us 0.50 hertz, right? So R is given by, as we have seen, as del F by del P. So we can say that this is del F dash. So we can write here 0.5 divided by del P dash, right? And R is how much? That is 0.025. So del P dash is 0.5 by 0.025, which will give the value of del P dash as 20. So this is 20 megawatt, right? So the power supplied by the generator at 49.25 will be how much? How much? That will increase further from 110. This is our 110. This is 100. So 110 plus 20 megawatt. Okay. So power supplied at frequency of 49.25 hertz is equal to 110 plus del P dash. This will give us 110 plus 20, that is equal to 130 megawatts. So this is the value of the power that will be supplied by the generator, right? Hence, we have calculated the value as 130 megawatt. Thank you.